Darkness. A low rumble shakes the silence. A lone observer stands on a quiet shoreline at night. The waves glow faintly in moonlight until the water suddenly pulls back, as if inhaling. Above, the moon hangs eerily low, impossibly close, its surface now larger, brighter, sharper. What you're seeing is the impossible. A moon that has broken free, a moon that is falling. The camera widens, showing the horizon bending under tidal chaos. If this ever happened, humanity wouldn't witness a single disaster. It would witness a sequence, a chain reaction that rewrites the fate of our world. The screen fades to black. This is what would happen if the moon started falling toward Earth. For more than 4.5 billion years, the moon has been our silent companion. Stable, predictable, it never moves closer. In fact, it drifts away a little each year. But imagine something changes, a cosmic disturbance, a gravitational disruption, an unseen force that slows the moon's orbital speed just enough to break the balance that keeps it safely in motion. Suddenly, the moon's orbit decays. It begins a slow, unstoppable descent, and the moment it starts falling, everything changes. To understand the scale of this disaster, we must understand the moon itself. It is a 2,160-mile wide world of rock and iron, weighing more than 73 trillion kilograms. Its gravitational pull controls the tides, stabilizes Earth's tilt, influences our climate, and shapes the rhythm of countless species. If it loses its orbital velocity, even slightly, gravity takes over, and Earth becomes the moon's final destination. At first, the change is almost invisible. Only astronomers notice it. Their instruments detect a shift, small but unmistakable. Warnings are issued, governments meet. The world watches the sky. Days later, the moon appears larger, brighter. Its light feels unnatural, almost intrusive. Tides swell higher than normal. Coastal regions experience unusual floods. Rivers reverse direction at their mouths. Weather begins behaving strangely. Nights no longer feel dark. A week passes. The moon falls faster. Tides grow violent, swallowing coastlines twice each day. Entire neighborhoods evacuate. Earthquakes occur more often as the moon's gravity pulls harder on Earth's crust. Volcanic systems begin waking from dormancy. Storms strengthen beyond anything seen before. Humanity realizes this is no temporary event. This is the beginning of global imbalance. Another week. The moon now dominates the night sky, huge, brilliant, and terrifying. Its pull nearly doubles. It drags at Earth like a colossal hand. The crust shifts more aggressively. Fault lines rupture. Massive earthquakes sweep across continents. Oceans surge in chaotic waves, sloshing violently between basins. Hurricanes grow to unimaginable sizes. People everywhere look upward and understand a painful truth. The moon is no longer a gentle companion. It has become a threat. A month passes. The moon approaches the Roche limit, the boundary inside which Earth's gravity is stronger than the moon's ability to hold itself together. Once it crosses this threshold, Earth will tear the moon apart. Its surface begins cracking. Dust plumes rise into space. Entire mountain ranges crumble. From Earth, the moon appears wounded, as though breaking from within. Scientists know what comes next. The moon is about to die. Earth's gravity stretches the moon until its structure can no longer withstand the strain. Cracks become canyons. The crust fractures. Then, with a sudden burst of catastrophic force, the moon shatters. It becomes a ring of debris, millions of fragments, from dust to continent-sized chunks, circling the planet. For a brief moment, the sight is breathtaking. Earth has rings. But this moment of beauty is also the countdown to devastation. The ring destabilizes. Fragments of the broken moon begin falling toward Earth. Not slowly. At incredible speeds, the sky ignites night after night. Massive fireballs tear across the atmosphere. Shockwaves roll over cities. Explosions echo across oceans. Tsunamis hundreds of feet high strike coastlines. Thousands of impacts scar Earth's surface. Ash and dust rise into the atmosphere, blocking sunlight. Temperatures crash. Crops fail. Darkness spreads across continents. Earth enters an impact winter. This is not simply the loss of the moon, it is the collapse of the system that shaped life itself. Without the moon, Earth's tilt will eventually drift wildly, creating chaotic seasons over millions of years. But long before that, the constant impacts, tsunamis, and atmospheric damage would reshape the world entirely. Astronomers believe something like this once happened in reverse. The moon formed when a Mars-sized planet collided with early Earth. Debris from that impact gradually came together to create the moon we see today. In this scenario, the process plays backward. The moon returns to dust, becoming a deadly ring that will eventually rain down until nothing remains. If the moon began falling, the destruction would not come from a single crash. It would come in stages: rising tides, crustal distortion, violent earthquakes, global storms, the moon's breakup, and the relentless bombardment that follows. The moon is not just a bright object in our sky. It is a stabilizer, a regulator, a quiet architect of the conditions that allow life to thrive. Its fall would be the undoing of the world it helped create, and it leaves us with a haunting thought. If the moon could fall, what else in our universe could suddenly change? And would we see the warning in time?